is just a short video on some of the basic knowledge and information behind oxyacetylene welding. Now, oxyacetylene welding is a gas-based welding process, and we're going to be looking at this over the next couple of minutes. So, before we look at oxyacetylene welding, just like every other form of welding, it is a fusion-based process. So oxygen and acetylene gas are burnt at the tip of a nozzle on a welding torch. Now, when acetylene is burned in pure 100% oxygen, it burns at a temperature of about 3,500 degrees centigrade. And when you consider that steel begins to melt at about between 1,500 and 2,000 degrees, you can see that this is quite a good process for welding when you don't necessarily have electricity available. So what you do is, as you can see in point A, in diagram A down here, you concentrate the hottest part of the flame, which we'll look at later, at the joint until the metal begins to melt and forms a weld pool. Now, because of the V shape of your welding joint, there will not be enough metal there to form your weld pool, so you will be forced to use a filler rod to fill up the weld pool to get an even and consistent weld formed throughout the whole process. Now, some of the equipment that's used with oxyacetylene welding. You have your oxygen cylinder here, which is usually color coded either white at the top or all white. And then you have your acetylene cylinder here, which is usually either all maroon or black with a maroon shoulder on the top. Now, this will become very, very important later. Other parts of equipment are the pressure regulators at the top here. And we'll come back to these, but there are always two dials in the pressure regulator. There's also a pressure adjustment knob on the front of it. You have your two hoses, blue for oxygen and red for acetylene. It is extremely important that you do not get these mixed up, as that can have serious problems down the road. And you have your welding torch. Now, if we look close up at the welding torch, when you are welding, you have your flame here, which is heating up your metal to form your weld pool. You have your filler rod coming in, and you have your solidified weld metal at the other end. This is very similar to TIG welding in that you have a heat source, in this case it's gas rather than electricity, creating the weld pool, and you have your filler rod to fill in the gaps in the metal. Now, when you are working with acetylene and oxyacetylene torches, there are three basic types of welding flame. The most common type of welding flame is a neutral flame. This is where you have even parts acetylene and oxygen. Now, you have a couple of different parts to the flame. The first part is the inner core. This is where the two gases are coming out of the nozzle but haven't yet ignited. Right in front of the inner core, you have the maximum temperature zone. That is where the most of the combustion takes place. And this point here, usually just in front of the inner core, that is the hottest part of the weld. Now, not all of the gas has burnt at this stage, so you still have gas burning all the way out to here at the very end here. So we call this our secondary combustion envelope, and this is where there's still heat, but it is not the hottest part of the flame. Now, if you have too much oxygen, you end up with a much more pointed flame. There's excess oxygen. You have a much smaller, more pointed inner core, and you have a much shorter, sharper envelope. And then lastly, a carburizing flame. There's not enough oxygen compared to acetylene, so you get a larger inner core. You get an acetylene feather, which is where the excess acetylene is actually pushing out past the inner core and is starting to burn out in this area just here. And then finally you have the envelope out here where the rest of the acetylene is burning with the oxygen. Now we will look at these in a little bit more detail as to what happens with the three different types of flames. Now, when it comes to the applications, we use our neutral flame most common. It's the most often type. So it's used in steel welding mainly. We use an oxidizing flame, that's, remember, where you have excess oxygen, and we're using that on brass, bronze and copper. So in other words, we're using those on non-ferrous metals. We need less oxygen, so we need more oxygen there to help burn away impurities. We use the carbidizing flame, which is less oxygen. We use that on aluminium and on steel alloys such as stainless steel. And because of this, we also use this with gas cutting as well. So we can use our torch. Now, it is a specialized torch, but it is still using a carburizing flame to burn through metal. Now, the equipment itself, it is important that you are able to recognize all the pieces of equipment in oxyacetylene. So the first one is that your oxygen is either black or black with a white shoulder, and your acetylene is either red or black with a maroon shoulder. You have gas pressure regulators, and there are two gauges on the gas pressure regulator. The first one indicates the pressure inside the bottle. The second one is the pressure that has been supplied to the torch. Now, the pressure gauge on the bottle will always be at a set temperature and will reduce slowly as you are using the gas. The pressure supplied to the torch, we can adjust that, we can vary that, but the most important thing is that when the system is not in use, the pressure indicated on the torch should always be at 0. In other words, there should be no pressure in the torch when you are not using the oxyacetylene equipment. We have two hose pipes, red and blue. Red is always acetylene, blue is always oxygen. We have two components called flashback arresters. Now, these in essence are like one-way valves for gas. They will allow gas to flow out of the bottle into the hoses. But let's say you're using the torch and you accidentally cut through one of the hoses with the flame. Well, the flame is obviously going to travel back up through the hose. And what happens is when it hits the flashback arresters automatically close, preventing the flame traveling back up through the hose into the bottle and thereby causing an explosion. And then lastly, the welding torch is the workhorse. We mix our gases together, we control the pressure coming out through the nozzle, and by changing the nozzle we can change different types of flame. So that again is just what the equipment looks like. Now, for the welding torch, and this is very important here, the acetylene collection always has a left hand thread. The oxygen connection always has a right hand thread. This is so you cannot accidentally connect the oxygen hose to the acetylene valve and the acetylene hose to the oxygen valve. The hoses are bought that way. You cannot make up your own hose. It has to be bought from a specialist oxyacetylene provider, and it is set up exactly the right way. So we control the gases using the acetylene valve and the oxygen valve, and it is good practice that the acetylene is always first. First on, first off. You turn on your acetylene, you light your acetylene, and then you turn on your oxygen to get your acetylene flame exactly the way you want it. And then when you're finished, you turn off the acetylene valve first, and then the oxygen, which is still flowing, pushes out whatever acetylene is left in the nozzle, clearing the flammable gas from the torch before you turn off the oxygen valve. So our safety features, the first one, which I've mentioned a few times, is the color coding system. So that's the first most obvious difference between the two of them. The second one, and you can just about make it out in these two diagrams here, the threads are turning in opposite directions. So you have a right hand thread and a left hand thread depending on which hose and which system you're using. You have your flashback arresters, which just look like a little cylinder on the pressure valves. And then lastly, you have this key here, this nut and this key. You always turn off the tap at the top of the bottle when you're finished. Now, finish up on this. We have a big problem with acetylene, and that is it is extremely flammable. That's its first problem. The second problem is it becomes even more flammable if you compress it under pressure. So that is the one thing you do not want to do. You can quite happily and safely compress oxygen into a cylinder, but you cannot compress acetylene. So what they have done is they put in a porous material into the bottle. Basically, it's like a sponge. That porous material is completely soaked in a material called acetone. Now, acetone can be used as an industrial cleaner as well, but one of the properties of acetone is that it can absorb 25 times its own weight, its own volume in acetylene. So by putting acetone into this, the acetylene mixes in and gets absorbed into the acetone, and then when we open the valve, it gets released under pressure. So it is not compressed, it is absorbed into the acetone. Now that's just a very brief summary of oxyacetylene welding. That's it.